Live from your local news leader, Matthew White, Amanda Brennan, and Central Illinois' most accurate forecast with meteorologist Jacob Dickey. You're watching The Morning Show at 9 on WCIA 3.
Welcome back to The Morning Show on this Monday. Yes, we have a Wise Guys segment for you, and today we're joined by Paul Kwiat again, and he's going to talk about the third and final part of our bee series. Hopefully we've been kind to our bees because we really need them, Paul.
Indeed we do. So yeah, this past weekend we honored D-Day. Today it's going to be Bee Day instead, I suppose. So yeah, just with the first slide, just as a reminder, we really bees are very important to us. There's lots of species. We need them to pollinate the flowers, and that's also very important as they're moving from one plant to another. They also are responsible then for 1/3 of our food supply.
Absolutely.
And of course they produce honey also. And we talked last time, we can go to the next slide, about the bees' eyes. So they actually have 5 of them. There are 3 on the top of their head called ocelli that don't really do much imaging. They're mainly to keep track of the brightness of the sky and keep them level. And then there are these big compound eyes that have these several thousand, you might say, pixels each. And if we go to the next slide here, so each of those pixels, which is called an ommatidium, it's got a little lens at the top, and then at the bottom it's got these roughly 9 photoreceptors. And you can look, there's this little electron microscope micrograph on the right-hand side from the 1969 classic Fine Structure of the Visual System of the Honeybee. I'm sure you subscribe to the Journal of Ultrastructure Research. Anyway, so there's these segments. There's like 8 of them, but then there's one underneath, and we can see that mostly they're green. They can see in the green, and then otherwise they see in the blue or in the ultraviolet. And so roughly it's about 2/3 green, 26% ultraviolet, 7% blue. Okay, so if we then think about what the bees can see, if we go to the next slide, what we see for what we call the visual spectrum, the visual part of the electromagnetic spectrum, is from about 400 to 700 nanometers. That's from a deep violet to a deep red. But the bees are actually going to see something quite different. So they can see down into the ultraviolet, but they can't actually see in the red. So that's going to affect what they see when they look at plants, for example. And so we could ask the question, how do we know that that's true? So let's come back to us for just a second. So there was this famous insect studier, entomologist, Carl Frisch, and he did an experiment, and he basically took some bees, and he wanted to train them to like a particular color. So he put some sugar water, I'm keeping this honey here, and he trained them, well, maybe they could see the color, maybe they can't. He trained them so that now they like this blue, and then he's going to put that blue without any food at all in the middle of a patch where everything is different shades of gray except for the blue. And then they put the bees on, and the question is, where do they go? And it turns out, they all go to this patch. So somehow they can see the blue. If you do the same experiment with red instead, then after you train the bees to like whatever that is, however they perceive that, and you put this out here, then actually they kind of go at random. They don't have any preference for the red. So that means they cannot see red, but they can see blue. And then they've done the same experiment with the ultraviolet. Okay, so if we go back to the slide again, we can just show this was actually, that's Carl Frisch. And if you hit the clicker again, you can see the actual this kind of data where they, on the next slide, where we can actually see where the bees are all clustered on the blue square in the middle there. Okay, so they can see that. So if we think about what plants look like then, because the bees can see in the ultraviolet, they can look very different than they do to us. So if we go back to go to the next slide. So this is, for example, what a bunch of different flowers look like to us, for example. And if we now just go to the next slide, this is what those look like to the bees. So they have all this other structure in them because they can see in the ultraviolet. And those ultraviolet patterns bring the bees into where the nectar is so that they can feed more efficiently. If we go to the next slide, here's something that you might think is a quite beautiful flower. Beautiful. Yes, exactly. But if we actually go one more, what this actually is a dandelion.
Just a plain
dandelion. Just that's how we see it, but the bees see the image on the left. So if we come back to us, I have this fun toy that I got here. This is a new toy. This is a thing that can see in the ultraviolet.
No way.
And so if we come in close, so I have here an ordinary dandelion. And we can see, hopefully, we can see this is what the dandelion looks like, in the yellow. But if we look on the camera, we can see that, in fact, it's got that dark spot in the middle. Let me show one more plant. This is an iris that I stole from one of my neighbors this morning while I was walking, so it's yellow. Yeah, but if you look on the camera, in fact, where we go, it's got this beautiful pattern in the middle, this really dark pattern that brings the bees to it so that they can find out. Whereas, again, to us, we don't see any of that. We just see yellow. We don't see any of this other UV pigment, basically.
So the darkness, the spots of darkness is what draws.
Yes, that's is like a bullseye to them to tell them where they should go for the nectar. Okay, so just you know, we can now sort of summarize. We've done bees for quite a bit here, so there's a bunch of different takeaways. You know, one takeaway, of course, bees are very critical for us in our food supply. They have 5 eyes, and those eyes are really, as we said before, the bee's knees, which we know is now a drink from the Prohibition. They can see the sky, the polarization of the sky, and they use that to navigate. They can also see very quickly, so very rapidly changing patterns, and as we've just seen, they can see in the ultraviolet, which is amazing. They perceive things very differently than we do. And maybe the last takeaway is that one person's weed is another creature's flower. So please use plants, you know, native plants that are supportive of the bees.
And take care of your plants so the bees can benefit.
Exactly right.
Alrighty, Paul. Thank you so much for all that information, and treat our bees with kindness. Still to come on the morning show, though, our meteorologist Jacob Dickey has our forecast and lets us know how long today's nice conditions will last throughout the